Today's session is going to be about things to consider when we design an application, how secure the application can be designed, and what are the services available on designing the application to ensure the security and not letting the security breach happens. Because when we talk about performance, cost, security as a parameter, security plays a vital role. It also tightly integrated with your brand value. So once there is a security breach in the organization, then it seeks media attention. People easily lose trust on your brand, and it's hard to bring back people once there's a security breach or you're out there in the media part. So that's why top organizations pay key detailing to the security when they design an architecture of an application from start. So now when we talk about security assets, there are like two ways of securing your application. One is a proactive way and then a reactive way. So AWS has service and there are mechanisms to protect your application in both the ways. So proactive is something where you stop before any security breach or security attack happens, and then reactive is something if something security breach happened, how to detect something have happened. It would be more worst when there's a security breach happened but you are totally unaware about it, but all over the world like suddenly there is a media news that there's a security breach happened. And you also need to be like covered in reactive approach in case if something happened at the proactive level is missed, to measure the metrics like how much data breach happened or what is the actual impact for your end user. So you need to be covered both proactive and reactive. It's all not the case like, okay, I have tightly secured my application in a proactive basis, so I don't need to be worried about reactive. You need to be good in both proactive and reactive when it comes to designing an architecture of your application from the scratch. I hear people saying that people move to the cloud just for offloading the responsibility of maintaining their infrastructure, or cloud can handle end-to-end of operations and management of the application. But in reality, it's not the case. So what AWS says something called as shared responsibility model. So when we say like shared responsibility model, hey boss, we take some amount of responsibility from our end as a cloud provider, and equally as a customer, you also want equal responsibility when you want to use our services. So that falls in all the category like availability, cost, performance. In the same way, we also have the equal responsibility when it comes to securing our application. So when we say securing our application, a few parameters that can come is something like how we are storing our data and how we are configuring our networking part. So here if you see, the AWS is responsibility for security of the storage, but not the security of the data. So two are different parts, even though it's looks close, like okay, so AWS will take care of storage, but what you store in the storage, which is the data, and who can access the data and how you store the data, it still falls under your responsibility. So same way when we talk about networking, like AWS can ensure the networking is integrated in part, but again, who you are allowing to your network, what ports you are opening, those things will fall under your responsibility as a customer. So same way like hardware part, AWS can ensure that your EBS volume or any hardware that would relevant to the AWS is not accessible via physically, but again as an end customer, you need to ensure you are storing it in a secured manner so that even if it is hacked, you still owns the responsibility of how it is being stored. So a few things to mention about like firewall configuration, like adding the security rules, and identity management, like who can access the service, who can delete a resource, who can create a resource. So all those things would come under the responsibility of customer when we talk about the shared responsibility model. Okay, so moving to the next one, we will talk about proactiveness, and then we will cover reactive services which AWS offers. Okay, so when we talk about proactive service, it's going to be you are going to stop any attack or a breach before even something is going to happen, or if it's something detected, you are going to stop then and there. So to make it easy rather than just being a marketing guy for AWS, like AWS provides security group, AWS provide WAF, and make it more theoretical. So what I thought of doing is to make it conceptual wise. So how can I make it conceptual? So if you are securing something, then there should be a reason why we are securing. There should be a mechanism why it should be secured in this specific way and why not in a different way, right? So that's what distinguish between a well-architected application and a non-well architected application. So for instance, you can stop an SQL engine at the CloudFront WAF level, or you can also add some rules at the backend of your server before serving the content. Both scenarios can stop the attack, but which should plays a vital role or like makes more sense to put it. So that's what the difference that would make, a significant difference that would make like on designing the application in a more secure way, right? So the way of approach, how I want to deal with this, something called OSI layer. This is something if you are a network candidate or if you're coming from background of networks, this is something you could never skip it, because this is how any system in internet works. The same process, like it has totally of 7 layers, and it starts with physical, so which is more like a data center or a hard disk or your computer, and then the data link layer where your data gets encoded and send it to the receiver. Then the network layer, it's going to be like where it should get it can be like from server to another server, or it can be like one server to another domain you are requesting for. Then the transport layer, it's more of like you are transferring your data from one to the another. Then session layer is like maintaining a session for each individual user. Like for example, you log into Zomato, then it can be a one of individual session for your own user, right? And your browser should your application should maintain what you are making in the first step of your initial session. For example, you can order a food, then the next API can be like making a payment, and next can be of you land into an order confirmation page and then tracking of order. So it's like 4 different applications at backend. It can be of all falls under the single session of your individual account. Then you have presentation layer where all the encoded and transmitted layer are decoded and ready to present to you. And then you have application layer, that's where you see it in your mobile, you see it in the Chrome browser, right, of the data. So it also works in like 2 ways. As a customer, you would request the application layer, then the data transfer via presentation layer is encoded, and then session is created for you, and then the data is transported and go back to the data center, and then all the way travel from physical to your application layer. So it works in both ways. So that's more of an essay answer in the college days. But to be practical, so this is something you must know, how the action flow works when you hit a website, how the data is transferred, so that now we can think logically how I want to secure my application in all the layers where my data is going to get initiated from the user machine till my server, and all the way back from server to the user machine. Is it clear, like how are we going to approach security using layer as a reference? So we'll start with the application layer, and then we will see what are the things we can protect it. So application layer is something a user is going to hit on the browser. For example, it can be Amazon.in for your purchase, so it's not even reaching till your backend data center, right? So then what are the things you can try to protect it? So few services that would cover under like WAF. So WAF is something called web application firewall. The difference between normal firewall and web application firewall is the WAF sits at the layer 7, the OSI layer, which means you can add protection based on your based on the host name, based on query parameter, headers and stuff, so that and that you can restrict any request that is coming to your domain or to your application. So I'm talking about the public facing application here. So all the other stuff like rate limiting. So rate limiting is something like you have an endpoint which can handle load like only 100 requests per second, but if there is an attack coming and bombarding your system with like 1000 requests per second to make the system down, then you would be configuring rate limit rules so that you can secure your backend infrastructure from getting it down. Then you have security groups in generic, like for example, to restrict the port for an instance. If you are not using fancy load balancer or CDN, but just running on a simplistic EC2, or even if you're routing the traffic from load by EC2, but you don't want the server to be directly accessible from the public internet, then you will be placing a security group like who can access your part. So those can be come under the initial level, but you can control via IP. Then again, application load balancer, which is going to be, you can restrict like what path you can route it, and who is giving you who can restrict like access for your domain. So those things can be do at the ALB listening rule. Then you have certificate. So whenever you hit a domain, you always see a lock screen on the browser, right, to ensure that the domain is secure. And also if you're using things like bucket or stuff, you can have bucket policies, who can access to a specific bucket. So those kind of things you can control at the application layer or at the upfront part. I might be wrong at the security group, like where it would play. I'm not sure whether it will stick at the application layer, but rest of the things would cover under the application layer. So security group, something that once request is coming to the server, then you can stop right there. Going to the next one, which is going to be the result, something called as OWASP, which is Open Web Application Security Project, and each year they give you a 10 list of vulnerabilities, the top vulnerabilities, and you go to the website and check what are the top 10 vulnerabilities for this current year, and generally that would be the top priority for you to get it protected of your application, so that you ensure that your application is secure. Then it's always go and refer top 10 security vulnerability and ensure that you get those protected. So that's something refer, and I would leave it as an activity for you. Like if you're interested, go and check it out. I'm not going deep into that, but that can act as a reference point to onboard what rules to go and what are the vulnerabilities that are openly available, which you need to consider as a top priority to get it protected. So moving from application layer to presentation layer. So presentation layer is something from the application layer you're requesting the data, right? And that layer they'll be going to transmit to your backend part. So then how are you going to transit this data? So you can encrypt the data when you transmit, and you can by default using a key management service like KMS, and then transmit it. And you can also, when you're using things like HTTPS protocol to transmit, by default it's going to encode and create a trusted channel, establish a connection between your system to the backend connectivity, and it's going to be passed. On top of it, if you want to transmit it more secure way, then you can use something like a key management service like KMS to encrypt your data and pass it out. And moving into the next part, which would be of session layer, where you want to maintain the application session, right? So a few things can be like Cognito. AWS Cognito provides user authentication, so that you can offload the authentication mechanism to the Cognito, rather letting your application public. If it's something like internal or you want to enable the login mechanism, then you can consider using Cognito. And also you need to ensure that you might be having session stickiness in concepts like load balancer. You try to enable that so that there's a session stickiness, it's there, and it's routes to the same EC2 instance for your application part. And again, credential management, right? So who can access using IAM policies, and also from this application or this user can do this XYZ action for the specific services. So those things would generally gets covered under the session part. For example, by default, an SSO, if someone is trying to log in using SSO, right? SSO something like you can use Azure Active Directory or other mechanism for logging in and get the AWS token, and you can set up timeout. By default it will be like 15 minutes. So once the CLI credentials is generated, and by default it will be 15 minutes when it is generated via SSO based approach. So that's the main reason, like you would have seen me like confidently sharing my tokens, right? So when I was screen sharing, like I fetch the CLI token from the console and share it publicly, because I know when I publish the video it's going to get expired within 15 minutes. So those kind of rather giving the CLI of permanent credential, you can use SSO authentication. So each time a new token is generated and you are secured, rather hard coding it some XYZ location, right? So these kind of mechanism you can consider when you are providing access to developers and way of authenticating application part. So moving from application layer, it's going to be the transport layer, right? So this is load balancers, like network load balancers can sit, and you are going to actually transmit your data from one to the another portion, right? Which means like from your browser to the another part. So then again, AWS provides something like ACM for certificate manager. So if you're using services like CloudFront or load balancer, then rather going and procuring certificate from third party like GoDaddy, you can register your domain, and then you can still register the domain in some other service like Route 53, and you can validate your certificate procurement from the Amazon certificate manager. And also you have something like KMS, which we spoke, and also the VPC and VPN comes in this picture, like who can access and who all been allowed to your area of networking from outside part. So all these services would generally comes into the picture of transport layer. So we move to the next one. Okay, so now we are talking about encoding, decoding part, right? So now if we go for the network layer, so network layer is going to be you are letting the traffic flow from the out, then you want to say where it should get routed to. So those were the clear picture, like you can control within your application. So for example, you have VPC route table. So if there is a connection from your VPC to another VPC, or are you letting the from internal application to connect via internet gateway to open up the internet access, or using NACL to restrict the IP access for your VPC, or configuring gate like transit gateway to let multiple PCs to connect to each other. So all those configurations would come under the network layer part, and so these are the few services which I listed. You can ensure that your network layer part is protected and your security is being maintained. No, it's not the case. You need to ensure that it's not that way, like who can access your network and who can let in. So one example I can say is that let's say you have a jump server. So jump server is something like which is having connected to your internet, which means someone can SSH or get into your server, and then you might be having instances at the public subnet, right? And so since both are part of the same VPC, and if someone can get into or like penetrate into your jump server, then still there is a high chance they can go and explore your private instances as well. So then you need to ensure that whom we are allowing here to the letting inside the jump server. It can be done via some rules like security group, like only these specific IPs are allowed, likewise. Or you can even keep some additional rules to make this specific connection, right, from your jump server to your backend server or database. Because once a security penetration happens, you don't know from where the attack is coming to you. So we should not take it light, like okay, I'm launching an instance in a public subnet, my database is in a public subnet, it's not open to internet, but there can be a culprit within your VPC which is exposed to the internet, and you should be like ensure that your route table is makes sense, that whichever an application is communicating from A to B is is actually needed, and only the respective port which is let to be open for the communication is only open and rest are being closed. And when you go to services like transit gateway, which is something like you have more than one VPC, then it makes your job easy, but then you also need to ensure that the connection establishment is done in a more sensible and secure way. So these are the main things you want to consider when you are configuring a route table. It's not always the case of, okay, I'm doing XYZ action so that my application began to work, but also considering security as a major parameter. The application is secure, that's something always need to keep in mind as an architect. So whenever there is a proposal is being in the organization, you also need to evaluate this parameter. Can someone hijack in this way, or is there any security breach possibility to do it in XYZ action? So it's not always like someone gives you a solution, you straight away go and implement it. Always try to see in this aspect as well. So the next one would be the data link layer. So this goes hands in hands with the previous one which we talked about, which is the network layer, because it's going to be route and also the how you are going to submit and stuff. So it's more like go hand in hand. I don't think of anything specific to data link layer, like how the connection happened. If you think I missed out something, then you can reach out to me or add it in the comment or pass it in the WhatsApp group. So moving to the next one, we have the physical layer, right? So here we can get underestimate saying that in the shared responsibility model, physical layer is something like totally controlled by AWS, right? So for example, the hard disk, how it is getting stored, and the data center, like who can access the data center. But also here it's not limited to the physical component, but also it translates to the availability, the EC2 instance, or in case if a data, let's say the hard disk is getting stolen from the center, then how can you ensure it's not a security breach? So for those things, you should consider using services like KMS, where you can store your data, sensitive data, in an encrypted way, so that you are not concerned about even if a hard disk has been stolen from the data center or any security breach happen on the AWS side, you are still get covered. It remains inaccessible. Same way like your access to the EBS volume, right? Like the hard disk one, who can access via the AWS console, like who have permission to that. And if you are letting from one server to the another server or from one Lambda to the another, can they program it in a way? So always ensure this would come in a way when you are dealing with cross-account IAM permissions. So you might be having a third-party service provider and you want to establish trust between your account the third party. They need to consider these factors, like if I provide this specific access, can they do any action which is not intended to perform? So always when you're configuring a user permission, you do at a resource level. So when I say resource level, you can go granular to an extent. This specific Lambda should access, for example, an S3 bucket of path/ABC. So even if you provide access for a third-party Lambda to hit or fetch content to your S3 bucket, you provide the bucket name and also you provide the specific path which is explicitly you expect to access, not providing granular access for all the S3 bucket or all the path within the S3 bucket. So that's something you need to keep in mind when you're dealing with user permission and role permission, and also rate limit rules and shield advance. So this is something I mentioned, you configure the rule at the WAF level, but that the ideal purpose of configuring the rule at the WAF level is to secure your backend infrastructure, right? So let's say you have an EC2 instance configured with a RAM of 1 GB, for instance, and it can handle like X traffic volume. If any request that's going to come X plus 1 or 2 cross the request, then your EC2 instance is going to down, right? It's going to be like shut down, or it can't handle load. You would generally see requests like 5xx or timeout. So in those cases, you would need to go with AWS products like shield advanced or rate limit rules. So this kind of scenario, we call it as DDoS, which is like your system can handle only X load and your competitor or attacker trying to bombard your system with XYZ request so that you can't handle anymore and you do it. Or it can be the other way around, that you set up an auto scaling group to scale up and you scale infinity and you get overpriced and your cost of your RAM gets increased. So to avoid those kind of attacks, you would generally go with shield advance or rate limit rules to get your system. So far we have talked about the proactive ways, right? There can be security breach happen, there can be like scenarios you are not aware like what's happened. So AWS have few services to get you covered when it comes to like reactive based approach. So what it's going to do is it's going to inspect your VPC flow logs or the DNS query logs or logs. So it's basically inspect the logs and then it's going to flag you like, okay, some unauthorized access being done or something unexpected behavior is going to happen. So those are the things you can do it using guard duty. I'm not going in detail about the service. Maybe we can do it as a separate session of the reactive approach, like what it offers and how we can handle and what are the things to consider. But for now, just know like there is some service called guard duty which is going to inspect your logs like VPC flow logs and your logs and Route 53 logs, and then it can alert you that hey, some breach is happening or some unauthorized access is happening. There is another thing, something called as Amazon Inspector, which is going to be like inspect your configuration of the services. For example, a security group in an EC2, you might be opening a port SSH for the entire internet, which is like anyone can access into a EC2 instance. So those kind of things, it would try to read your configuration and then flag, hey, this is not the best security practices, but your application has been set up in this way. So to get those inspect, you can use service like inspect to go further. So again, we can plan for something, a deep session. Like if you're interested, let me know. So then you have something called Amazon Conf. So let's say you as an admin providing permission to your developer, because you don't want to be a bottleneck decision saying that, hey, any changes that should go via my supervisor. It's good to have a certain level of control, but if you're going to be rigid on that part, then there can be a slowdown in the production changes. So what we can do is like you can use service like config, like Amazon config, which it's going to get notified whenever there is any changes happen on a specific service. Or you can also set rules like in security group, if this XY parameter matched or any specific configuration is getting changed in XYZ service, then get notified me. So those kind of things you can set it up. You can also integrate with tools like Slack, so that a message is automatically populated on each time, or an email based alert also you can do it. So these are the things you can do at the reactive based approach. In case if there is a security breach happen and you want to backtrack who did or what time it happened, so for such scenarios you have AWS CloudTrail, which is going to track each and every API calls. It's not just via console. Like if some action is performed via console, you can see like who logged at what time and what action has been performed. Even if you're using the AWS SDK or CLI or Terraform, all are nothing but just the API call to the backend AWS. The same thing in the console also. Like if you go and click a button like create S3, it's doing nothing but creating an API call to the backend AWS to perform some XYZ action. So this AWS CloudTrail is going to record each and every action for your application. Either you create, you log in, you log out, or you destroy, or you modify, you update, going to have a log for it. By default, to record a log at one time, it's free of cost, but if you want to duplicate the logs, then you're going to pay extra for it. I'm not going detail into it, but you just know that you can backtrack like who did change. Let's say there is a system which you are sure that when you onboarded it was not port, it's not open. For example, port 22 is not open, but then you want to backtrack like who opened the port. You can go and see like for which resource what change has been done and what time and who did that. So you can't escape the security part when you go with the reactive approach. Okay, so yeah, so that's mostly for today, like to get covered of securing your application and in a more architected way. Okay, so if you have any specific doubts, you can come